So let's look at the behavior of this function as s approaches infinity, which means that as s grows larger and larger. Now to look at the behavior of this function, we are going to use the intuitive approach or the table method to come out with the behavior of this very function. Now we are saying that s is growing larger and larger, so the values that we can pick for s can be s is equal to 10, 100, 1000, 10,000, and so on and so forth. So let's write down our table and then fix in the values. So let's pick out the value for x. As s grows larger and larger, we can take 10, can take 100, 1000, 10,000, 100,000, and so on and so forth. Now let's find the value of x from this function. So we are going to get 1 over 10 so 1 over x, which is 10, we are getting what? 0.1. 1 over 100, we are getting 0.01. 1 over 1000, we are getting 0.001. 10,000, we are getting 0.0001. 100,000, we are getting 0.00001. So you can see that as s grows larger and larger, what is the value of this function approaching? We can see that as s grows larger, so if you are to take a figure like 1,000,000,000, you will see that the value for this is going to be 0.000001. So you see that as s grows larger and larger, this function will approach what? 0. So we can say that the limit of this function as s approaches infinity is what? 0. Now what if we find the limit as s approaches infinity of 1 over x exponent 2? Now this one will round to 0 very fast. What about the limit as s approaches infinity of 1 over x power 8? This one very fast. So we can generalize and say that the limit as s approaches infinity of 1 over x exponent n is equal to 0.